Okay, today we're going to go through the Friday, the October 2023 paper from IAL Physics Unit 4, which is on further mechanics, fields and particles. We're going to just do the multiple choice first. So turn over. Hopefully you can see things clearly. Okay, I've already made some notes because I've been through this once before. I'm just re-recording it to ensure clarity improves. Okay, so the first question is about a nucleus of an isotope. The isotope is osmium, and it tells you it contains 76 protons and 190 neutrons. The question is simply knowledge about these two numbers, nucleon numbers. Which of the following can be used to represent the isotope? The shorthand notation. Now, I'm just going to zoom in a bit because in the answers, the question is, the figures are a bit small. So hopefully you can see better that A has 76 at the bottom and 266 at the top. Only two of them have 76 at the bottom. So it has to be A or B because the bottom number is the proton number and the top number is the mass number. So hopefully you can now see the 76 in A and B, whereas in C and D they got the charge number at the top. So the charge number always goes to the bottom and the protons are the charged particles. So you notice A and B, and the answer is A because the top number is the mass, so you have to add the neutrons to the protons, which will give you 266, which is A. Question 2 is about a car traveling in a straight line, so straight horizontal road. There's a drag force experienced. That means that's the only force that's acting on it for a time of 15 seconds, causing the speed of the car to decrease. It's a deceleration question, but they want you to give the answer as a change in momentum. Well, that's the impulse equation, or force is rate of change of momentum, delta mv over delta t. Giving the numbers, we know the force, we know the time, so what we want to work out quite simply is delta mv. So if you change the subject of the formula, you will get F times delta t, multiply the two, the answer comes out to C. Okay, they all have the same units, which are all correct, kilograms, meters per second, which is mass times velocity. Okay, question 3 is about particle physics and the use of a linear accelerator. So just going to check if I can get the focus to be a bit better. Okay. The tubes of a linear accelerator, or LINAC for short, get progressively longer along the length of the LINAC. Okay, so why is this? Which of the following is the reason for this? Well, A and B talk about the frequency of the applied potential difference. Well, you just need to know this. This is just testing your knowledge in the frequency is constant. So the PD is already set. So just like, for example, in the UK, the frequency of mains is set at 50 Hertz. The frequency of the LINAC is already determined, and it's determined to allow the electrons to get, or the charged particles to be accelerated each time they go through one of the tubes. So as they are accelerating, the particles do accelerate. Now, whether they gain mass or not is irrelevant in this question because the question is asking about the tubes of the linear accelerator. So it has to be D. The particles must spend the same amount of time in each tube. So if they're going faster and the time that each cycle of the PD goes on for is constant, the only way you can make sure that they're synchronized is that the lengths get progressively longer as the particles go faster. Okay, now carrying on with these questions. The next one is about magnetic flux. I put the equation there. Phi is magnetic flux. B times A is the equation. B is the magnetic field strength, and A is the area that's linking with whatever it is. So it could be a coil. So if you've got a coil and the magnetic field strength is in Teslas, and the area that is interacting with the field is known, you multiply the area, so it could be the area of a coil. If it's at right angles, you don't need to think about the sine theta, which sometimes is used, but over here, you just want to know the units. So you multiply the magnetic field strength, which is in Teslas, by the area, which is in meters squared. So these are standard SI units, so the only answer can be A. There is no equivalent. Teslas times meter squared is also known as Webers, okay, which is another given unit for magnetic flux. I hope that's clear. Number 5 is the famous Rutherford scattering experiment. So it said, which of the following, and be careful, they've put it in bold to make sure you read it carefully, which of the following is not a valid conclusion from Rutherford's scattering experiment. So use alpha particles. I think the experiment was done around 1910. So, and this will become clear to you why I've put this down. The nucleus contains most of the mass of the atom. That indeed was one of the conclusions, so I've ticked it. B is the one where you've got to think twice about, because it says the nucleus contains protons and neutrons. Well, it does contain protons and neutrons, but they hadn't discovered neutrons until 1932. So that wasn't a valid conclusion from the Rutherford scattering experiment. They couldn't know that until the neutrons were discovered way later. So just carry on reading the next questions and you'll see that these are also valid conclusions, so that will prove the point. C says the nucleus is charged. Well, the nucleus would have to be charged. That was a conclusion from the Rutherford experiments, and it moved the understanding of what the nuclear atom was from the plum pudding model which went before it. You have to make sure you have read up on both the plum pudding model and the Rutherford's experiment. They expect you to know what the observations were, what were the conclusions, and how they did actually, the method they used. Okay, so this one's talking about the conclusion. Another question you could get, what were the observations that were made? They sometimes come in multiple choice and sometimes come in the longer written answers, which is a bit more tricky if you don't get your language accurate. And finally, D, which is also a valid conclusion, the nucleus is very small compared with the atom. We now know that the nucleus of the atom is 10 to the minus 15 meters, and the size of the atom is 10 to the minus 10 meters. That's an order of 10 to the 5 times smaller. So the answer must be B. Question 6 continues with particle physics. And this is talking about the particles' tracks that are shown. It says the particles X and Y are produced by the decay of a kaon at point O on the diagram. Now, you will notice that we do not need to know what a kaon is to be able to answer this question if you read the question. So don't always be confused when you read the question. Just make sure you have read every part of it clearly and that you know what it's asking. Which of the following can be concluded from these tracks? Can we conclude A, a magnetic field acts into the page? No, because they haven't told us anything about the direction of the magnetic field. We cannot conclude anything. If we were given the charges of X and Y, we might be able to use one of Fleming's rules to be able to work out the answer, but we can't. So it's a question mark. X is a positively charged particle. Again, we don't know if X or Y is positively charged. We do know that they're oppositely charged because they're in the same magnetic field and the curvature is in the opposite sense. So we know that they're both charged. So my eyes quickly go to D, and I know that D is the answer. And it says that Y is an electron. Again, we don't know anything about the nature of X and Y. All we can conclude from this is that X and Y must have the positive charge. Okay. Over the page, question 7 is about particle physics. Again, this time we're looking at a magnetic field and the rate of curvature, or the amount of curvature, how much it's curving. Well, you can see from the diagrams that X isn't curving as much as Y. Y is actually going in a circular motion. Clearly, you can see the full track is circular motion. Well, X also is going in a circular path, but the radius is much of curvature would be much bigger. The diagram shows the path of these two particles, X and Y, moving at the same speed in a uniform magnetic field. So we already know some information about it. Now, the theory comes from circular motion, where mv squared over r can be equated with bqv, and this is a common equation which will come up in every single Unit 4 paper you will try. So the radius of curvature would be m times v on the top and b and q on the bottom. But since v and b don't vary, we can almost ignore them and say the radius of the curvature is directly proportional to the mass and inversely proportional to the charge. So now you've got to read what the question is asking for. Which row of the table describes the properties of y compared with the properties of x? Okay, so we're focusing on the properties of y. Well, we can see the properties of y, we want it to end up with a small radius. Well, if the mass is greater, for y, they mean than x. If it's greater, by being greater, look at the equation here. If the mass is greater, the radius will be larger, which is against what we see. So that's one cross against that. Going to part B, it says less than. Well, if the mass is less than, smaller mass means smaller radius, so that ticks a box. Go to the next one. Greater than. If the charge is greater for y, then charge is on the bottom, so a greater charge will also lead inversely to a smaller radius. It gets 2 ticks. Automatically, you know this looks like the candidate you want to go. If you want to double check, C says the mass is no different, so therefore it's not going to give us the answer. It's going to not change anything about the radius. And then you go to the second box where it says the charge is less than. Well, if the charge is smaller, the radius should be larger, so you know C is wrong. And D has an X next to it already because it's greater than. So I would go straight for the answer B. I wouldn't bother to go into the details of the others, but if you want to, you will find that the same logic will apply and you will be left with B as the answer. Okay. Question 8 is about a toy airplane. Again, this is circular motion, so you can see how particle physics or a toy airplane can be part of the same Unit 4. So circular motion, the mathematics of it, or the further mechanics that you need to know how to convert from one unit to the other. They've given you that the plane is completing 12 revolutions in 2 seconds. That means it's got 2 revolutions per second. One revolution is 2 pi in radians. They want you to work out the angular velocity in radians per second. So you know that omega is 2 revolutions per second, which would be 4 pi per second, but the answer isn't given in 4 pi, so you've got to multiply 12 divided by 6, which is what the 2 revolutions is, multiply to convert from revolutions into pi. 12 times 2 pi divided by 6. The only answer which has that algebra is B. Okay. We're now coming to the end of the multiple choice, question 9 and 10. So, capacitors use natural logs. So I've put the natural logs equations there for you. A capacitor discharges through a resistor. This is an experiment, a required practical, so you must make sure you know all the different forms of these equations that you can use. In this case, they want to talk about charge. The time constant, of the circuit is given as 5 seconds. Well, time constant is equal to the capacitance multiplied by the resistance, which is in the equation at the bottom of the power, e to the minus t over CR. You want to work out what is the time taken in seconds for the charge on the plates of the capacitor to halve. So that means Q, which will be the second charge, will be half of Q at time 0. Okay, so you can put Q over Q naught, so you know it's a fraction of a half. And then you can take natural logs, so you can move Q on this side, take natural logs. Natural log of a half is equal to then the taking logs of both sides will leave minus t over 5. If you're not confident with natural logs, you need to go and make sure you watch a video on using natural logs. Now, the natural log of a half gives you a minus number, so it will actually cancel. If you change the fraction upside down, you can get rid of the minus sign, and you'll see that minus on the other side, minus ln of a half is equal to ln 2. Now again, as I said, you need to make sure you're familiar with taking natural logs and swapping fractions round. So if you then change the subject of the formula to make t the subject, it should come up to 5 ln 2, and the only one with that answer is D. So that's the answer for question 9. Question 10 is also to do with circular motion. So this time it's a car travelling over the hump of a bridge. So it's a humpback bridge. As shown, I put the force diagram on there. The bridge forms part of a circle, it tells you, of radius r. So we need to know that because of the centripetal acceleration. The car has a mass m and travels with a constant speed v. Remember, it's very difficult to use these equations unless they give you constant speed and a constant radius. I always tell my students they have to remember that physics is a simplification of reality, so they have made these values constant for you. The car is at the top of the bridge. At the top of the bridge, the weight is pulling it down. There is a reaction to the weight of the car from the bridge, and now if we read the question, you'll see that's what they want us to work out. Which of the following expressions gives the force from the bridge on the moving car? Well, the force from the bridge on the moving car is another way of saying what is a reaction of the bridge to the car. So we know that if you resolve these forces, mg minus r is the resultant force towards the center of the circle. That means, because it's moving in circular motion, it will be equal to the centripetal acceleration multiplied by the mass. That's Newton's second law, in other words. The unbalanced force, mg minus r, equals the mass times the acceleration. Okay, rearrange the equation. R will be then equal to mg minus mv squared over r. It's a simple matter of algebra. Okay, well that ends the multiple choice section. I hope you found that useful. And if you found it useful, please give us a like on YouTube, share it with your friends, and if we get a lot of requests, we can do more model answers or explanations of A-level physics questions. I will then move on to do the questions 11 onwards in a separate video. Thank you very much for watching.